Inverse functions. Definition. Let f be a one-to-one correspondence from set A to B. The inverse function of f is the function that assigns an element B belonging to set B the unique element in A such that f of A equaled B. The inverse function of f is denoted by f to the negative 1. Hence, f inverse of B is equal to A, when f of A is equal to B. Note that the inverse function of 1 is not 1 over f. A one-to-one correspondence is called invertible because we can find an inverse function. Next, we have a graphic that shows the mapping from set A to set B. So I have circle set out for set A with a point A in it, circle for set B with a point B in it, and normally we see line drawn from A pointing to B, and we're defining our function f of A. So you take element A, apply function f of A to it, and you get B, which means B is equal to f of A. And that's our typical situation that we see. We also, now that we know that this is a one-to-one correspondence, we can draw a line with an arrow going from B back to A, and this is the inverse function of B. So point A can be said to be equal to the inverse function of B. And then you can also generalize this, and you'll see just an arrow from set A to set B defined as f, and an arrow from set B going over to set A, and this being the inverse function. Let's look at another example. Let f be a function that maps z to z, that is integers to integers, be such that f of x is equal to x plus 1. Is f invertible, and if so, what is its inverse? To determine if it's invertible, we have to figure out if it's one-to-one and if it's onto. So the question, is it one-to-one, is resolved by setting f of x1 equal to f of x2, and then substituting in our values. So we've got x plus 1 is equal to x plus 1. This would be x2 and x1. And now we subtract a 1 from both sides, and we get x1 is equal to x2. And that is the definition of one-to-one. The question of whether this thing is onto is pretty obvious. That is onto, yes. And then we can say, okay, if y is the image of x such that y is equal to x plus 1, then x is equal to y minus 1, simply isolating for x. And therefore, we've got, so y minus 1 is the unique element of integers that is sent to y by f. So we end up with the inverse function of y is equal to y minus 1. Now we'll look at another example. Let f be a function from the set of reals to the set of reals with f of x being equal to x squared. Is it invertible? And we always have to ask ourselves two questions. Is it one-to-one? And is it onto? It must be both of those things in order for it to be invertible. So the first one, is it one-to-one? And we've looked at this earlier, and no, it is not one-to-one, because we could take f of negative 2, set that equal to f of 2, and those are both equal to 4, therefore that is not one-to-one. Also, it is not onto, because we have no inverse function for, say, a negative 1 in the set of real numbers. In the next example, we'll show that if we restrict the function f of x is equal to x squared from the set of non-negative real numbers to the set of non-negative real numbers, then f is invertible. Once again, we have to show two things. So first, we have to show this thing is one-to-one. So we'll say if, and we could use x1 or x2, or in this case I'll pull f of x is equal to f of y, where x and y are both elements of the domain. Then we'll make this x squared is equal to y squared. So if we move the y over to the other side, we'll get x squared minus y squared is equal to 0. And then we can factor this out, and we get x plus y times x minus y is equal to 0. So either x plus y or x minus y is equal to 0. So either x is equal to negative y, or x is equal to y. Both are non-negative, so x must be equal to y. Therefore, function is 1-to-1. Next, we look at whether or not the function is onto. So with the question of whether or not this is onto, we say when the codomain is non-negative real numbers, then we can say because each non-negative real has a square root since that is true, then we have an inverse function of y, which is equal to the square root of y. Therefore, since it was 1-to-1 and it's onto, this thing is invertible.